Yeah. Welcome back. So there's a video that I'm going to have you watch. I didn't want to do a video the first day back, but explaining like with 2x2 systems, what we've been doing, those are just lines. And so it's pretty easy to understand when you have two straight lines that they're either going to be parallel to each other, they're going to sit on top of each other, or they're going to cross. Like that's something that like a 9-year-old could figure out and understand. These are not lines. Every time you have an equation that has x, y, and z, that equation does not define a line. It defines what we call a plane, a flat surface, like an infinitely long flat plane that tilts in space. And so the idea of three flat surfaces kind of floating around in space and viewing how they interact with each other is way more complex than just two straight lines. So I didn't want to get into that with you today. And there will be no weird ones today. There'll be no that have no problems that have no solution, or like no parallel planes, no overlapping planes, stuff like that. Um, so there'll be a video at some point. I don't want to commit to a day, but at some point I'll have you watch a YouTube video. We'll watch it together in class, and it'll sort of illustrate for you how planes interact with each other in space. Because it's like I said, it's where how lines cross. That's elementary, but planes, not so much. It's a different scenario. So we're just going to mechanically go through this for a day or two. It's not difficult at all. It's just the thing I'll caution you about is that there's a lot of math that has to go right. So if you're someone who's prone to forgetting a negative, this is going to be a really nightmarish week or so for you. So you want to hold yourself to account for every little detail. Am I above those mistakes? Absolutely not. Like none of us are. So we just have to do our best every time we do an operation to be very tight, hard on ourselves and say, like, did I do it perfect? Check every calculation, check it twice. Because these are a lot harder for me. Like when you come up and say, I'm getting a fraction, or I got this, blah, blah, blah. Going back and trying to diagnose where an error occurred with these is a lot harder for all of us. So that's kind of my pep talk for you, is just try to be as perfect as you can as we go through this, okay? Again, not difficult, just a lot of math problems that have to go well in succession. You have to do like 30 or 40 things right in a row to get to where you want to be, okay? So this is a 3x3 system. We call it that because there's 3 variables and 3 equations. So we've been doing 2x2s, 2 equations, 2 variables. We're only going to use elimination. Okay, I've tried teaching it the other way, and it's just not even practical. It's not useful. It's not appropriate. And so we're going to focus just on the elimination method. It's the only method for this that really makes sense to use. So, and we're certainly not going to try to solve them by graphing, because trying to graph planes, holy smokes, no way. So we're going to do elimination exclusively. So here it is. And this is a level 1. If this were an Algebra 1 lesson, I would introduce this as a fluffer puffer, or a level 1 problem, meaning it sort of self-eliminates. So as you look at the columns, anything catch your eye? Those Y's are nice and tasty, aren't they? I can't say that about the Z's. I see a 6 and a 3 and a 1, and the X's I see a 4 and an 11 and a 3. And I don't like that. But the Y's are what make this a level 1 problem. So this is a self-eliminating system. Your first goal, this is where you really need to listen. Your first goal is to eliminate a variable, but you have to do it twice. So you have to pick a variable and eliminate it twice. And what's going to happen if we eliminate the same variable twice is we will create a 2x2 system. That really, at the end of the day, is the goal, is to take a 3x3 and say, can I make you a 2x2? Because then we can solve 2x2s, pretty much in our sleep. So we're going to focus on the Y's, and I wanted this to be our first example coming back because it just, like I said, it just takes care of itself. So there is no prep work to do with a system like this. So I'm just going to draw my commitment line and I'm going to get going. So what we do, and this is not an optional step, so don't be stubborn about this. I'm going to call you on this, and I quite frankly won't even grade your work if you don't do this. So you're going to communicate to me. It's for yourself, but it's also for me. You're going to communicate what you're about to do. And you would notice, of course, that if you take the top equation and you add it to the second equation, that something good will happen, right? So what we do is we say we're going to take row. Oops, I'm sorry about that. I picked the wrong tool. We're going to take row 1 and we're going to add it to row 2. That is the notation that we use when doing linear algebra like this, is we call the equations rows, lowercase r. So r sub 1 means top row, r sub 2 means second row. So I'm announcing my intentions as a courtesy to anyone who might have to read my work. And so row 1 plus row 2, and then you draw a little arrow. Don't put an equal sign, because the equation's already going to have an equal sign. So you say, okay, row 1 plus row 2 leads to this, and here we go. So if you take every element over here in row 1 and add it to every corresponding element in row 2, what do you get? How many X's do you get? Good job. You get negative 7 X's. And I'll put a little box around that, and then I'm going to erase it. Just I know some of you get anxiety and don't know where things come from. That was just me focusing on that little portion of the problem. I took the top X and added it to the X right below it. I didn't expect anything cool to happen there. All right, so row 1 plus row 2 yields negative 7 X's. How many Y's does it yield? None. So we don't even write it down. Okay, it's just an elimination. I wouldn't cross it out, quite frankly, because that's going to kind of gum up stuff that you want to look at later. So just know, of course, it eliminates. How many Z's do we get? Good. So we have plus 9 Z's, and that's going to be equal to what? 10. Very good. Okay. See if I can move this little fella up here out of the way. There we go. Any questions so far? So what we just did is we eliminated the Y. But the thing now is, and there will be situations where you might then get tempted to then go, ooh, there's something else. Like you might say at this point, not in this example, but see like a 5Z and a negative 5Z and go, ooh, I'm going to eliminate those. Don't do that. You have to eliminate the same variable twice. So once we commit to 1, he's our target for the first 2 steps. Okay, what 2 rows are we going to add together next? Adding row 2 and row 3 will not help because the Y's will not cancel. This one right here is currently off limits. Yes, if we add row 1 and row 3, then we're in good shape here. So we're again going to announce our intentions. We're just right here going to write row 1 plus row 3. You would understand why if you don't put that down, I'm just not really going to be a part of this with you, right? I don't want to try to read your mind and figure out where things are coming from. So that's just our announcement of intention, and now we're going to do the math. So we're going to take every element from the top row, and we're going to add it to its corresponding element in the very bottom row. The middle row is not in play right now, right? So how many X's do we get? Nice. How many Y's do we get? None. Good. There was another elimination. How many Z's do we get? Nice. And what's our constant? Negative 42. Very good. Any questions so far? So understand that, I mean, and again, if you're a math anxiety person, you don't see this, but if you're a comfortable math person, you see with clarity what we've accomplished. And what we've accomplished is we just made a math problem right here that we just spent the last week or so before break solving. That's just a classic simple 2x2 system. And to make this problem even easier, not only did we get it down to a 2x2, but we got it down to another self-eliminating fluffer puffer. We won't always be this fortunate, but in this case, we couldn't ask for a simpler 2x2 than this. What makes it so nice? Yeah, the X's are already self-eliminating. So again, I don't have to do any manipulation on this. I can just draw my line of intention and say, I'm ready to go. You do not any longer need to show statements of intention. You don't need to do row one, row two. That's only applicable when you're working in a 3x3. At this point, it's obvious to anyone with any common sense what you're going to do. So we're just going to add straight down. How many X's do we get? None. How many Z's do we get? Correct. We get 16 of those Z's, and that's going to be equal to what? Good. And from here, we have now completed step one of the puzzle. And if we divide both sides by 16, what is Z? It does. So we've navigated the minefield and we've worked our way down to having 1/3 of our answer done. The answer to a 3x3 system is not a point in the plane like we're used to. It's not what we call an ordered pair. It's what we call an ordered triple. And so when I write my answer, like I always do, I'm going to put a space, but I'm going to put 2 commas because there needs to be room for X and Y and Z. And now I'm going to put the one that I know in its proper home. Where is the Z going to go? At the end. So we're going to stick a -2 right there at the back. And now what you do is you work your way in the exact opposite order from which you came. We started with a 3x3 and went to a 2x2 and got to what we call a 1x1. Okay. Now we're going to take our 1x1 and we're going to put it back up into the red, which is a 2x2. And then we're going to take those 2 answers and storm the castle. We're going to take our Z and whatever we choose to find next. Well, it's not really actually going to be up to us, but we're going to take the 2 that we know and plug them into one of the equations in the OG system, the triple system. So now that we know that Z is -2, we can put that where either of these yellow arrows are pointing. You can put it here, or you can put it here. You cannot put it into the big system. Why not? You don't have to know how to answer this question, but if you do, it would be a good sign. Let me ask you this as a question. Follow this purple arrow. If I were to put -2, say right there, and I change that Z into a number, how many letters would be left in that equation? And that's not good, right? What we're trying to always do with equations is eliminate a letter so that we can get it down to just one letter. And if you can get an equation down to just one, then any monkey at the zoo can solve a one variable equation. So that's why we don't want to go back to the original huge system yet. You got to go into the red one, the 2x2. So we're going to take the Z. Do you guys want to do the top red or the bottom red? Bottom. Okay. So the bottom red equation, and this is where things can get a little bit cluttery. So sorry. I try to be as neat as I can, and I hope that you try that as well. So the bottom equation right here, I'm going to circle it for you, is going to say 7x minus 14 equals -42. Okay, so I'll draw a little arrow for you. If you decide to go back and watch this video, or anyone who is watching the video, whatever, then could see that, okay, that's what we did is we took that equation, we changed the Z into the numerical value that we know it is, and we got ourselves down to a 1x1. One equation, one variable. How do you solve that little red equation? Add that 14, move it across. Make sure you remember to add the 14. What is -42 plus 14? It is -28. And then we divide by 7. And what is X? It does. Okay, so we can now complete the second part of the puzzle. -4 goes in the front spot. And it's at this point now that you can go storm the castle. You have enough information now to substitute into the big guy, because if I change any equation two of its letters, I'll only have one left. So now we're back to the original big guy. Do you guys want to go with row one, row two, or row three? I quite frankly couldn't care less. Three is fine. And again, you'll get the same result with any of them. Okay. So it's not like it matters what you pick. Nothing matters as long as you don't make math errors. All right. So if we're going to take row three, so that's what I heard you guys say you wanted to do. We're going to take this big purple equation and we're going to change his x into -4. And we're going to change his z into -2. And that will leave us with a 1 by 1. Okay. So what will the first term in that equation be? -12. The -4y just, of course, stays because it's y that we don't know yet. And then what's the back term? -2. Okay, so plus a -2, we just put in a -2, and then that equals -30. Okay, so now we're focused on this little purple equation. And I say if you and I collectively have done our jobs for the last year and a half together, then you can solve equations like that without any troubles. Are we perfect? No. Do people do crazy things? Yes. But, we can do this. First thing I would do is combine the like terms on the left. The -12 and the -2, since they're on the same side of the equal sign, they just make -14. And then I would add that 14 across, giving me -4y equals what? Nope, and that's how quick it can happen. -16, right? So -30 plus 14 is -16. And then if you divide both sides by -4, you get y equals 4, which completes the puzzle, which means that if you were to graph those three planes given in the original problem, the only place that they would touch each other or coincide is at the point in space, -4, 4, -2. And the XYZ planes in space, now that we're graphing in 3 dimensions, we have our normal plane that faces us. You guys that play Minecraft can appreciate this. You have an x-axis that goes to the side. You have a y-axis that goes up and down, but now you have a third axis, the z-axis, that creates three-dimensionality, right? Like, your XYZ coordinates in Minecraft, it's the same idea. So X is one side, Z is the other horizontal, and Y is the one that goes up and down. So same with this. So to get to that point, if you wanted to like illustratively sort of see it, you would go left 4 from your point of view, left 4. You would go up 4, and then you would go to -2, which would shoot towards you, -2. Got it? So that's a simple example. I don't intend that we're going to have a lot of work time today because I do have more examples. I have 4 of them, I think. I have 5, and they won't take as long, I don't think, now that we've gotten through the awkward first one. Any questions just about the basic mechanics of it? Okay, good. Let's get to number 2. So make sure you copy these down very deliberately and correctly. Okay, so we have 6x plus y minus 5z. And I just cross my z's so that they don't ever look like 2's. So I don't know if that's something that you're interested or if you already do that. The next one, we have 4x plus 2y plus 4z equals -10. And then we have -6x minus 4y plus z equals 16. So you notice right away why this is not a level 1 problem, right? You can't look at any one column and say, booyah, like those, whatever they were, the Y's, I think, in the first one were pretty tasty. We don't have that here. So does any one particular column, though, seem more attractive maybe than the others? No, column. One. Yeah, the Y's, honestly, the only one I would probably steer myself away from would be the Z's. I like the X's because I can turn 6, 4, and 6 all into 12. And I like the Y's because, like Kennedy said, I mean, that's pretty tasty. I can turn a 1 and a 2 into a 4, and then I don't even have to mess with the bottom one. At the end of the day, the Y's are probably going to be our best choice. Okay. So what we're going to do now is we're going to rewrite the entire system. I didn't used to teach it this way, and I wish I could go back in time. And, as teachers, we get better as we do our jobs. There's no, you don't just suddenly know everything. But I've learned over the years that there is a best way to do this, and it's got to be what we're about to do. Okay, we can make this messy. This is not messy. What we're going to do is we're going to modify this system, but our goal when we modify this system is to make everything in this row be either a 4 or a -4. Okay, so we're choosing this path because it feels like it's probably the path of least resistance. So what do we have to take the top equation and multiply it by? No, by 4. If I take the top equation times 4, I'm not worried about what happens to the x's and the z's and the -13. I am, though, focused that that y that I'm pointing to will become a 4y, and he'll then play nice with the -4y at the very bottom. Okay. How about this second row? What do we have to multiply him by? 2. And again, the focus is I'm just looking at one number. I have a very clear-cut mission. And notice that we didn't have to multiply either of these by a negative because the -4 is already going to play nice with those positive 4s that we're about to create. So this is a very neat process. It takes just a little bit of extra time, but trust me, it's worth it compared to other methods that I've done in the past. So we're going to take the top equation, we're going to rewrite it, and it will say 24x plus 4y minus 20z equals -52. That's just everything in the top row being quadrupled. There's a lot of collateral damage there. We made some pretty big numbers, but we accomplished our mission. We made a 4 right where we wanted to make it. That's all that matters. What's our green, the second one, going to be? Yes. And then the third row, in this case, I didn't have to do any modification. I will just copy it over. Make sure you always just recreate a 3x3 system in this first step. And now I can draw my line. The line signifies to me readiness. The line signifies that I can do this now. It's now a self-eliminating system. We made it one. So let's add downwards. So if we go down column number 1 right here, remember columns go up and down, right? Rows go sideways. Which 2 rows first off do we want to add? Okay, so I'm going to go down here, leave myself a little bit of room. So I'm going to announce my intentions that I'm going to add. Thank you for that back there. I'm going to do row 1 plus row 3. Did I have to do that one first? Absolutely not. It's just the one I heard. I love it. Okay. That will give us an elimination. How many X's do we get in that elimination? We get 18 X's. How many Y's do we get? None. How many Z's do we get? -19. And what will our constant term be? -36. All right, now we need to do another elimination. Combination is, by the way, what you are supposed to call this. It's called a linear combination is what we're doing. I don't really care if you call it that. Where's the other elimination going to occur? Row 2 being added to row 3. Remember not to put an equal sign there. You don't want stacked horizontal equal sign. So the arrow can be replaced with like a colon or something else, but not an equal sign. All right. So focus. I make them, you make them, we all make them. It's so easy to let our eyeballs wander and look at the wrong thing. So focus your attention right now. You're doing these 2 rows. It's easy to wander and go and add the wrong things. How many X's do we get? How many Y's do we get? How many Z's do we get? Nice. And what's our constant term? Perfect. You see now that unlike that little warm-up problem number one, this one is not a self-eliminator. So we have some choices to make. To me, there's a very obvious correct choice. I don't know what you would perceive this to be, but which variable feels like it's probably the easiest one to kill? X's for sure. The Z's are a bit nightmarish. I'd have to turn them both into probably, what is that, 961s? I could do it, but no thanks, you know. So to make those X's eliminate, what could I do? Very good observation. We don't even have to mook around with the top one. The top one's like, I'm good. Just turn that guy below me into a negative version of me and we're good to go. So I'm going to take that top equation and I'm going to copy it down. 18x minus 19z equals negative 36. And the new bottom equation is what? Nice. Okay, I can now draw my horizontal line. That line, as I've said a million times, to me signifies like commitment, readiness. I'm ready to add these, eliminate these together. So when I add straight downwards, how many X's do I get? I get none. How many Z's do I get? I get negative 100. And that might feel scary. We're not scared, but we get 0. 0 is the best number in the world. It causes anxiety for some creepy reason. Some people think, oh, I did something wrong. I go, oh, come on. It's just a dang number, right? If we divide both sides by negative 100, what do we get for Z? Correct. So we now know 1/3 of the answer to the puzzle. So I like to write it in yellow. So I'm going to say, here is my commitment. Here is my final answer. I'm going to put 0 in place of Z. And now I have to work in a very particular order. How many uniquely different red equations do you see on the board? There are 3. This one up here, number 1 is unique. Equation number 2 is unique, and equation number 3 is unique. But this one is not unique. It's just a restatement of a previous one. So you at this point can pick any one. I feel like you'd be pretty weird if you didn't pick number 2, but that's it's your business, I guess. I'm going to pick number 2 since I'm the guy with the fake pen. Okay. It just feels like the least intimidating. They'll all work. So I'm going to take 0 and I'm going to put it right at the end of this arrow, right there. What's that equation going to say? 2x plus 0 equals negative 4. Don't even have to put the 0. What does x equal? It does. So we can now go down and complete the second third of the puzzle, leaving us now with what is the y? And this is where you storm the castle. You now have enough troops to go into the 3x3 and do some damage. If you know 2, you want to plug into where there are 3. So we're going to take a -2 and a 0, and you go back to the OG. I wouldn't generally do my modified triple system just because it's usually going to have bigger numbers in it. So I'm going to go back to my OG equations. Which one? Top, middle? You like the third? Interesting selection. Okay. So we're going to do this equation because someone said we should, and that's perfect. So we're going to change x into what again? So -2 is going to go in place of x. And what's going to go in place of z? Is 0. This is shaping up pretty nicely. What's -6 times -2? 12. I don't even have to put the 0, right? Next step. Sure. 16 minus 12 is 4. Divide by -4. It does. And now we can go down and complete the puzzle. So we can put a -1 in place of y, and boom, done. Okay, the only thing that's going to happen in this next example is that it's just going to be a little bit more prep work as we go. If you're understanding mechanically what's going on, the only example today that's going to stump you will maybe be the one after this, the fourth one. And I may omit the fifth one because the clock's telling me that I probably will have to. So let's get to it. So this would be a level 3 problem, the one we're about to do together. And you'll see, you'll know why. I think. Maybe not. This one's pretty weak sauce. Yeah, whatever. -4x plus y plus 3z equals 5. -3x minus 3y plus z equals 15. And 2x minus 5y minus 4z equals 5. This question does not apply to this problem, but someone's eventually going to ask because every time someone does, it's a great question. Can I divide equations just like I can multiply them? Yeah. So if you ever see an opportunity where dividing one of the equations by like 2 or 3 would help, get down with your bad self. Dividing and multiplying are like, kind of the same thing. So which variable is the most attractive to you? Okay. And how are you going to kill those x's? Good job. So really, this is just where this level 3 differentiates itself, is that there's no real shortcut. Like that last one, we could turn a couple things into 4s. Here, we have to modify all 3 equations in the system. So we're going to take, and our goal, let me just make sure we're all hopefully clear on this. Our goal, and Mari just kind of got us running on this, is we're going to make all these into 12s. I'm sure you figured that out from what she said. Okay. So every equation is going to require some modification. We do not have to tinker with signs. We've already got one that's different than the other two. Had they all been negatives, we'd have to be aware as we went of switching one. But we're good to go again. So what are we going to multiply? You said by 3, 4, and 6. And that will produce a column of x's that eliminate. Perfect. So what is our new top equation going to be? Perfect. Second row.
6.
And the last row.
Equals 30.
Yeah. And that just, it happens all the time. Like, it's so hard to get through this unit because we are humans, and the big ones are what we just saw happen, forgetting to multiply one of the numbers and missing signs. Those are usually the two that I go back and go, there it is right there, So now I'm going to draw my line and I'm ready to commit. Adding downwards, how many x's do we get? None. Good. By the way, what do we, I apologize. We didn't do an intent. 1 and 3. Thank you. So let's do row 1 plus row 3. I just kind of put the, what do you say that? Put the cart ahead of the horse. Is that how that saying goes? Yeah, something like that. Row 1 plus row 3. No x's. How many y's? -27. How many z's?
Positive 49. It's 9 minus 25.
Yeah, so it's this term plus this term. -15. Good. You're right over there, Mari? Oh, you were just already on this side over here. 15 plus 30. There's that 45. Okay, good. Next elimination occurs where? Good job. How many X's? Y's?
Negative 43.
Nice. How many Z's?
Negative 40.
Yep. And the constant term? Good. So this would be where some division might be worth your time, depending on how comfortable you are. You know, the fact that we have and are allowed to use calculators means that really it's not necessary. But I feel like knocking the numbers down might be something you're interested in. That's up to you. So, which variable first off is probably going to be the tastiest? I like the Z's. They both end in 5 and 0, which means they're easily convertible into something that's divisible by 5. You just, again, you have to decide, is it worth your time to take the top equation and divide everything by 3, and then take the bottom equation and divide everything by 2? That's up to you. I personally am not worried about it. So let's take this top equation and let's multiply it by 4. And then let's take this bottom equation and multiply it by -3. And I had to do a negative because both my Z's are being stubborn. They're both negative, so one of them has to get the old flipperoo. And if we do that, what will the new 2x2 system say? Well, I can help you with the math, or I see you grabbing calculators. Always a good idea. -108x
60.
minus 60 Z's equals
40.
180. Okay, and then in the second row, multiply everything by 3. How many X's do you get? That's why. I so apologize for that. I don't know why I put X there. Thank you. Y. Thank you, Kennedy. That's a Y. And how many Y's do we get in that first? Yeah, positive 126. And then in the second space, nice, equals
Negative.
-270. So I go back and forth. Like I think I don't want to take back what I said. If you want to knock numbers down, go ahead. It's just time. Depends. You have to prioritize. So worth it. It's up to you. We're not scared. When we add down, how many Y's do we get? Correct. We get 18 Y's. How many Z's? None. And then 180 minus 270 is -90. And if we divide both sides by 18, Y is -5. So we now know that Y is -5. So the answer is -5 goes in the center. Now we have to go with the red equations. I would not use those white ones that we just created. Like you'd have to be a crackhead to think that's a good idea, right? So stick to where the numbers were smaller. I think that's the red ones look pretty tasty. So we're going to put -5. Do you guys want top red or bottom red?
Top.
Top red is fine. So right where this little yellow arrow is pointing, zoop, right there, we're going to change that letter into a -5. What's -27 times -5? 135. So we have 135 minus 15Z equals 45. Subtracting 135 gives us -15Z equals -90. Divide both sides by -15. Z is 6. So we can now complete 2 out of 3 slots. And now it's time to storm the castle. Steve, you okay, bud? Okay. So now -5 and 6 are going to join hands. He says, I'm the Y, you're the Z. Let's go storm the castle and rescue our homie X. And so go back to the original. Which equation seems the tastiest? I like the top one. He seems pretty friendly. So this equation in the white box is going to be where we go. At least it's where I'm going to go. And I'm going to change the Y. So follow these little purple arrows here. That Y is going to change into -5. And the Z is going to change into 6, leaving us with an equation that says -4x minus 5 plus 18 equals 5. Okay, combine the like terms on the same side of the equals sign. You get -4x plus 13 equals 5. Subtract 13, you get -4x equals -8. Divide both sides by -4, you get x equals 2. And the puzzle is complete. So what we're going to do is, I have about 4 minutes. Okay, we're going to start the fourth example, and we're not going to finish it. I don't think. That would be amazing if we did, but common sense says no. So you're going to get this equation number or system number 4 copied into your notes, and we'll probably talk about maybe the first step, and then we'll continue this conversation to start class tomorrow. So our next system is -2x minus y plus 3z equals -8. Our second system, or our second equation, is 2y minus 5z equals 10. And our third is 3x minus 4y plus 4z equals -5. When I teach Algebra 1, I feel like horizontal and vertical lines should be the easiest thing that we do all year, yet they somehow are not. Some people just can't get it in their heads that if it says x equals 2, that you graph a vertical. I don't know what it is. I feel like something like this is another one of these situations where what we're about to talk about should be really, really easy. Somehow, some people like to make it not that, which is weird. So what do you notice? Second equation is missing an x. And some people go, oh, that's a problem. And then the people that really understand math go, that's not a problem. That's someone just hooking me up. Remember, I said this 40 minutes ago. Our job is to kill the same variable twice. And whoever wrote this problem already did it for us once. But the only downside is that the choice has been made, right? Which variable was eliminated before we got to the party? Then we have to do it again. So our goal, what we're going to do when we start class tomorrow, I see some of you packing up, and boy, I wish you just knew how much that made me want to say dirty words. Our goal is to take the x's here and here and make them both the same. Because again, do you notice that there's a missing x right here? We're going to do it again. And what is that number? We want to make that a 6, and we want to make that a -6. And that's pretty close to already there. So let's get this set up, and then we'll pack up. What are we going to multiply the top by? 3. And what are we going to multiply the bottom by? Correct. And I don't want to make you late to second hour, so we are going to stop right there. All right, I'll make a note that that's exactly where we got to. And the lecture tomorrow should only take about 7 or 8, 10 minutes tops, and then you'll have a bunch of work done.